Okay, we're going to start the next program by Lawrence, and the title is Real-Time Security, How DAST Elevates DevSecOps Practices. Please.
Thank you for the introduction. Welcome, everyone. So first, a little bit about myself. I look after what's called solution engineering at Sneak. How many people have heard of Sneak? Few people. Basically, we do DevSecOps, helping customers build more secure applications. What is a modern application? It's code, it's open source packages, containers, infrastructure as code, all those things we protect, but not here to talk about that. What I'm here to talk about really is interesting topic is DAST, Dynamic Application Security Testing. How does that fit into your pipeline, right? Into your current DevSecOps or DevOps processes? Because traditionally, that's been quite difficult, right? And slow, as we'll see. I'll get into the details later, but that's sort of the premise of the talk. I've been in software development for 20-something years. About 10 years ago, I got into application security because of the website that I was building got hacked. So it kind of elevated my thinking around security, right? And quite passionate about it now. Right. So what we're going to do is just give a few definitions. If you haven't heard of some of the terms like DAST, SAST, SCA, we'll just start there. And then talk about why we actually need DAST for full security coverage. Some of the challenges of implementing traditional DAST solutions. And then how to actually integrate DAST into a CI/CD pipeline. And I'll do a bit of a demo just to illustrate the point that things get missed during development, i.e. security vulnerabilities, et cetera, that get deployed to production. And hence why we need DAST. We need other tools as well for a full coverage, but you can't just rely on scanning stuff from the source code, right? We need to do it at runtime as well. Make sense? Okay. So some definitions. If you haven't heard of these, that's fine. SAST, Static Application Security Testing. So this is scanning your first-party source code, most probably from the IDE itself in real time. So as I sort of write code, or these days as Copilot is generating code or other AI tools that you're using, we want to sort of trap those vulnerabilities as you're writing the code, right? Think of it like spell check for code. Put a little squiggly line under the SQL injection or cross-site scripting, what have you. SCA, software composition analysis. This can also be done in the IDE, sort of the farthest left in the process, to make sure that all the open source packages that you're using in your applications do not contain sort of well-known vulnerabilities, CVEs that are out there as well, right? And then DAST, Dynamic Application Security Testing, is basically scanning the application you've built at runtime and incorporating things like environmental configuration, et cetera, which could cause a vulnerability to be exploited, okay? So why do we need DAST? SAST and SCA can give you sort of indicative results around what vulnerabilities you may have in the code, but they're not always entirely accurate, okay? They may give you sort of 70%, 80% view on what vulnerabilities you have. That's because we may have false positives, right? They don't know the full context of how applications are deployed and how users are going to actually interact with your system. There's some smarts in some SAST and SCA tools to sort of figure that out. You may have heard the term reachability, right? To figure out if you have a library, for example, that's downloaded, is there a piece of code actually calling that? That's a sort of a basic analysis, but it doesn't have the full picture of production, let's say, right? So you have false positives, and that has been a huge problem for developers because you have all this noise and they don't know which issues to fix first, right? It'd be better to sort of prioritize those issues based on so-called risk factors like, is it deployed? Is there a reachable path? Is the package been loaded in memory, et cetera, in production, right? And then with false negatives, meaning that it actually misses stuff in development, probably because of an environmental configuration. And actually, that's the demo they're going to show later, is where SCA or SAST miss potential vulnerabilities, and then we find them at runtime. Okay. So we need DAST, right, to sort of plug the security gaps that SCA and SAST actually miss out on, right? And there might be sort of more complex attack vectors that a DAST system can send multiple payloads to exploit an application, which obviously was too difficult to do with just the source code. Okay. I think this picture is quite good, this Venn diagram, because it sort of illustrates where there's overlap between the three different areas, but also some of the unique properties that they each have. So for example, with SAST, secrets detection is a big one, right? If you have secrets in your code and they get deployed to production, it's sort of too late, right? This is like, API keys or AWS secret keys or username passwords in your code or in configuration files or properties files that you have in the project folder or in the Git repo, for example. SAST does a very good job at finding those, right? That's a good use case. On the SCA side, things like SBOM generation, you may have heard of software bill of materials for working with your third parties. So if you consume Docker containers or packages from third parties, you should tell them to give you an SBOM, which highlights all the different dependencies they have in their applications, right? And you can scan that before you put it in production. And then DAST obviously can look at that runtime configuration, right? So that's sort of the unique properties of all three. But where there's overlap is the standard well-known vulnerabilities. So OWASP Foundation have the OWASP top 10, you would have seen. Things like SQL injection, command injection, cross-site scripting, cross-site request forgery, all these different techniques for attacking websites. That's where the overlap is, because we're looking for that in the source code. A lot of open source libraries have those known as CVEs, and the DAST tool is generating payloads specifically to target those particular weak spots as well. SANS 25 is another one. There's other standards as well. And then, of course, well-known CVEs, things like Log4j and, Log4Shell, different vulnerabilities that exist. The DAST system can actually target specific payloads to those known CVEs, okay? Hope that makes sense. So the challenge actually with DAST though is one on speed. So it's very slow actually to run a DAST scan. If you've ever used DAST before, it may take several hours depending on how big the application is, right? A small app may take 30 to 60 minutes, right? It depends on how many endpoints the application has, pages, URLs, API endpoints, etc., right? Because the first phase of a DAST scan is to sort of crawl the website to get a sitemap, and then run the scanning, executing different exploits against those particular endpoints, right? So that can take a long time if you've got a very large application with thousands of endpoints, okay? So the question is, how do you automate that if it's so slow? Obviously, we don't want our pipelines to take more than 30 minutes, hopefully less than a minute, but that's not an option for your sort of main pipeline, right? So we sort of need a different approach for if you want to integrate DAST into your CI/CD pipelines. Now, I think traditionally, and you can agree or disagree, but a lot of people who have implemented DAST do it on an ad hoc basis. So they sort of do manual testing once a week, once a sprint, once a quarter, or what have you, sort of like pen testing, I guess. But there's no reason why we can't be doing this sort of more frequently, right? So one of the solutions is to have a separate pipeline, and it could be asynchronous as well. Like you want your main pipeline to be synchronous, because if you want to have some checks in there to break the build, if there's any critical or high vulnerabilities in your main pipeline, you actually want to stop deployment, go back to developers so they can fix the issues, right? That's sort of that continuous feedback that you're getting. But with a DAST scan, because they take so long, maybe you make it asynchronous and have a different workflow, as I'll talk about in a minute. The other thing you can do is do incremental scans. So we want to only test the delta of changes. So any new page or new URL that exists, only scan that, right? We probably should do like a full DAST scan on a frequent basis, once a week, once a sprint, what have you. But on a daily, hourly basis, whatever, you can do these incremental scans. Okay, most enterprise DAST tools will have this feature. Right, so this is what it could look like. So on the left-hand side, you've got your sort of, I would say, normal or main CI/CD pipeline, where the developer's getting feedback, they're building code, they're checking into Git, what have you. It's running the CI processes, running all the scans they need. In this case, probably SAST, SCA, because they're quite quick, right? Working on source code is quicker. And then deploy if everything is green, right? That's fine. We don't want to disrupt that, but have a secondary process. So what I like to talk about is if you've got your development environment, i.e., a server that gets deployed to on a daily basis or hourly basis, depending on how frequent your builds are, that's sort of going up and down all the time, right? If you're getting ready for a release, you create a branch, a tag, what have you, and release it to a UAT environment, which is more stable, only gets deployed to once a week, for example, where the QA team is doing the user acceptance testing, then that's a good place to run the DAST scans. So after you've deployed a UAT, you'd kick off this secondary pipeline, which would complete the workflow. And that is for all the issues that, and this could be asynchronous, right? All the issues that it finds as part of that sort of deep scan of the website is automatically create issues in a ticketing system like Jira, for example, or ServiceNow. And that's what the developer would look at as the backlog of the security issues, right? Now, you want to have an intelligent system that retests the particular issue that's been fixed. For example, if I'm a developer and I see an issue in my environment and I mark it as fixed in Jira, that should automatically issue a retest in my DAST system to test in fact that the issue has been fixed. And if it hasn't, reopen the ticket, right? So you want that sort of bi-directional linkage between the DAST solution and the ticketing system, right? So you can, I guess, get the best of both worlds here. And especially if you do the incremental scans, the right-hand side becomes a lot faster. I don't think even with the incremental scans, you would want to do it as part of that main pipeline, partly because that development environment is going up and down anyway. And you want to pin the security issues against an actual release, right? Not just from the trunk deployment. Does that make sense? Okay. Any questions so far? Good. All right. It's going to run a quick demo over here. Get this sorted out. You still hear me? All right. I've got 5 minutes, so let's go. So what I'm going to do is, can you see that all right? It's probably a bit small, but I'll show it in the demo. Basically, I've got a simple Spring Boot application deployed on Tomcat, right? I'm going to run a SAST and SCA scan with SemGrep, which is an open source scanning tool. And it's not going to find anything, right? But there's a man-in-the-middle attack exploit that's comes from the Tomcat J session ID. So basically, this application is mixed HTTPS and HTTP. And at some point, the J session ID is sent from the browser to the server in clear text. Okay. And imagine you were on at the airport on a public Wi-Fi or at Starbucks on a Wi-Fi, what have you. Someone could spoof your Wi-Fi session, get the J session ID. If you're on internet banking, use that to actually log into your account. Okay. All right. So, is that big enough, or should I go one more? Okay. All right. So basically, I've got my code here in this directory. Uses Gradle for the build file. All the source code is in the source. You can see the source here. It's basically just login controller and admin controller. I start the application. You'll see here that starting on port 8443 and 8081 for HTTP, right? So both HTTP and HTTPS are supported. Come over here. Pretty simple website. Just allows me to log in, admin, password, like that. Yes, it's a bad password. All right, so I come back over here and just do the scan. So I just need to type semgrep scan. It will pick up all the files in my directory. It's going to connect back to the registry, which is the semgrep cloud, to download the rules in case there's any new ones. And it shouldn't take too long. You see it's doing a SAST, SCA scan. And then hopefully we don't find any issues. Yeah. So 0 issues, 0 findings. So as a developer, I'm happy to deploy this, right? But if I come over here, I'm going to run a DAST scan. Now I'm just using this open source DAST tool called Watapi, with this endpoint /admin. It's going to generate a report that's going to show me all the issues with the actual running application. So I can just copy this file here. It gives me a nice HTML report. Found a bunch of stuff, some configuration things, but I want to jump down to this one here, secure flag cookie. So it's saying the secure flag is not set in the cookie JSON ID, so JSON session ID. So as a attacker, I can see that in plain text. So to illustrate that, I can load up Burp Suite. Burp Suite is just a tool to sort of allow you to intercept the traffic between the browser and the server. And it has its own little browser here. It's sort of like a proxy where you can load up the application and see the traffic in the background. You can see it's capturing the background there. If I do that again, admin, password, and come back over here, you can see the payload for the /admin. Now, obviously, if I was an attacker looking at this traffic, I can see the JSON ID there in plain text, right? And if I actually create a curl command from Burp Suite, I can run it on the terminal like this. You can see here, don't worry too much about the other settings, but it's sending the J session ID back, which allows me to log into the admin page, right? Now, just to prove that that works, I can take off the J session ID, and it should just redirect me to the login page and actually create a new J session ID. Like that. Oops. Yeah, it's on a 302 and it's redirected to the login page and actually generated a new J session ID. So if I have that J session ID, I can log into anyone's internet banking. I mean, it's a pretty trivial example, but you can see how easy it is to miss stuff during development, but obviously DAST found it in production. All right, just wrapping up here. So some of the key takeaways, we need all 3 of these things. I think hopefully that came through. Full security coverage. Take this off now. And DAST is reducing a lot of noise, particularly where you've correlated vulnerabilities from SCA, SAST, and DAST, right? To give a developer a backlog that's actually prioritized based on real issues, right? And then just think about the operationalization of DAST, where in your pipelines, use incremental scans, have a separate pipeline, as I talked about, where you should be able to automate it just like the other tools as well in your security stack. That's it. Thank you. Any questions? Do we have time for one or two questions, or just one question? Any question? Yep. Do another one. For the Zoom.
Yeah, any other tools that you can recommend besides Wapiti? I noticed you were using Burp Suite. Maybe is there a CLI version of Burp Suite we can use, or a CLI version of OWASP Zap, or maybe SNCC, maybe?
Yes, you can use SNCC, but I'm not here to sell your product, right? But I mean, there's hundreds of open source tools. I think Burp Suite is quite good, but I think there's a lot of configuration. You have to generate your own payloads and rules and stuff and manually configure that. Whereas I think most security teams or developers just want stuff out of the box, right?
Yeah.
Yeah. Good question.
So are there any recommendations you have then? Like maybe top three?
You said it, right?
Okay, got it. I see.
So SNCC just acquired a DAST company actually called Probly, which we're integrating into the rest of the stack. So check it out. All right. Thank you very much. Arigatou gozaimasu.